A steel-clad superhero weighing 227 kilograms lifts the 65 kilogram civilian 50 meters into the air for 10 seconds. How much power do the thrusters on the superhero's feet exert in lifting the superhero and the civilian if they start from rest and constantly accelerate to a final velocity of 30 meters per second?
Okay, so we're going to set the ground down here as a reference point for where height is 0. Next, we have the superhero carrying the civilian, who are both represented by stylish boxes. The superhero's thrusters are lifting the two into the air. Starting from rest, they uniformly accelerate to a final velocity of 30 meters per second when they are 50 meters above ground. For reference, they're moving and accelerating in the positive y direction based on this diagram.
So let's start with our general equation for power, which is equal to work over time. Seeing as we have time and we're solving for power, we have to find the work. So let's go to conservation of energy. We can see that both the initial potential and kinetic energies are equal to 0 because they start from rest and from ground level where h is equal to 0. We know from our energy equations that the final potential energy is equal to mgh and the final kinetic energy is equal to 1/2 mv squared. So we can solve for the work done by the thrusters by plugging in our values for the final potential and kinetic energies. After finishing our calculations, we find that the work done by the thrusters is equal to 274,480 joules. Keep in mind that in your energy equations, the mass that you use will be the superhero's mass plus the civilian's mass. We can then plug the work we found into the original equation, power is equal to work over time. Power is equal to 274,480 joules over 10 seconds. After simplifying that, we find that the power done by the thrusters is equal to 27,448 watts.